Somewhere in the Milky Way, right now, there is a dead planet. It has oceans, or it had them. The atmosphere still carries faint chemical traces. Oxygen, methane, the kind of signature that should mean something is alive down there. But nothing is. Not anymore. And the terrifying part? That planet probably had cities. Real quick, where are you watching this from? Drop it in the comments. I want to know if people from every continent are seeing this, because what I'm about to tell you affects every single one of you equally. Okay, there's one explanation for why the universe is completely silent. No signals, no megastructures, no alien hello. That the physicists who study this problem take the most seriously. And it's not where is everyone, it's what happened to everyone. And here's the part that should stop you cold. The math says whatever happened to them, it happens at exactly the stage we're in right now. I'm going to walk you through the full picture, every clue, every dead end, every explanation that almost fits but doesn't. And I'm going to save the answer for the very end of this video, because once you understand how we got there, the answer hits completely differently. So, let's start at a lunch table in 1950. Los Alamos, New Mexico, summer of 1950. A group of physicists eating lunch. Someone mentions flying saucers, they were all over the papers that week, a few jokes, some eye rolls, and then one man at the table, almost to himself, asks a question that nobody has been able to stop asking since. But where is everybody? His name was Enrico Fermi. He'd already helped split the atom, and this question, this casual lunch table question, turned out to be one of the deepest problems in science. Here's why it's so uncomfortable. The universe is 13.8 billion years old. It contains 2 trillion galaxies. Our galaxy alone has between 100 and 400 billion stars. We now know, thanks to the Kepler Space Telescope, that nearly every star has planets, and a meaningful percentage of those planets sit in the habitable zone. The right temperature, the right distance, liquid water possible. The math says the universe should be loud, packed with signals. We should have stumbled across something by accident by now. Instead, silence. 65 years of listening, billions of frequency channels scanned, the most sensitive instruments humans have ever built pointed at the sky. One anomaly. One. August 15th, 1977. A signal so strong, a researcher named Jerry Amon circled it on a paper printout and wrote a single word in the margin. Wow. It lasted 72 seconds. It matched the exact frequency physicists had theorized an intelligent civilization would use to broadcast. And it never came back. Not once in 47 years of follow-up observations. One signal vanished. Never repeated. That's what 65 years of searching has found. So, where is everybody? 30 serious explanations exist. We've thought carefully about all of them. Most of them sound reasonable at first. A few are genuinely hard to dismiss. And one, is left standing when you push every other explanation to its logical limit. Let's go through the uncomfortable ones first. Maybe we're just looking wrong. Maybe alien signals exist, but they look like noise to us because they're so efficiently compressed that our instruments flag them as static. Physicist Claude Shannon proved in 1948 that a perfectly encoded signal is mathematically indistinguishable from random background noise. An advanced civilization wouldn't be broadcasting old-school radio waves. It would be transmitting in ways we literally don't have the framework to recognize yet. That's a real possibility, but here's the problem. We're not just listening for signals anymore. We're looking for physical changes, waste heat from megastructures, industrial chemicals in exoplanet atmospheres, stars that behave slightly wrong because something enormous is orbiting them. The James Webb Space Telescope is checking planetary atmospheres right now. Still, nothing.
Maybe the universe is just too big and we're too early. Civilizations existed but burned out billions of years ago, and the distance plus time means we'll never overlap. That's real too. But physics says dead civilizations leave residue, altered atmospheres, engineered structures that outlast their builders. We don't see residue either. Maybe life is genuinely rare. Maybe the chain of conditions that produced Earth, the right galaxy location, the right star type, a Jupiter-sized shield deflecting asteroids, a large stabilizing moon, plate tectonics acting as a thermostat, a magnetic field protecting the atmosphere. Maybe that specific combination is extraordinarily uncommon. That's actually a strong argument. But Kepler and Webb keep finding that the ingredients for life are everywhere. The building blocks aren't rare. Something further down the chain is filtering things out. And that word, filter, is where everything gets darker. In 1998, an economist at George Mason University named Robin Hanson published a paper with a question built right into the title. The Great Filter, Are We Almost Past It? Here's the logic. Between simple chemistry and a civilization that can broadcast signals across the galaxy, something is extraordinarily difficult to cross. Some step, maybe several, almost nothing survives. Hansen called it the Great Filter. And here's the pivot that changes everything. The filter is either behind us or ahead of us. If it's behind, if the hard part was something early in the biological path, the origin of life, the leap to complex cells, the emergence of intelligence, then we're the rare exception that made it through. The road ahead might be relatively clear. But if the filter is ahead, if the hard step is something that happens after a civilization reaches our level, then the silence means civilizations regularly arrive where we are and then stop. Something terminates them, reliably, before they become a lasting presence. These two possibilities make a testable prediction. If the filter is behind us, life should be rare. Look at Mars, look at Europa, look at exoplanet atmospheres. Find nothing. Sterile worlds, chemistry without biology. Good news, we're the exception. If the filter is ahead, life should be common. Biology gets started easily. It just doesn't get far. And here's what one of the leading thinkers on this said out loud. Finding microbial fossils on Mars would be the worst news in the history of humanity. Not the best, the worst. Because it would mean the filter is almost certainly ahead. Now here's what we're actually finding. In 2023, the James Webb Space Telescope analyzed the atmosphere of a planet 120 light-years away, K2-18b. It found carbon dioxide, methane, and traces of a molecule called dimethyl sulfide. On Earth, that molecule is produced almost exclusively by marine life. There's no known non-biological process that generates it at significant levels. That detection is still being confirmed, but the direction of the evidence, telescope after telescope, mission after mission, is pointing toward a universe where life gets started easily. Which means the filter that's been silencing every civilization before us is not at the beginning of the path. It's somewhere after technology. So what kills them? Here's where most people stop reading or watching, because the next part is about us. Every single technological threat on this list, every scenario that could end a civilization at our stage, we are currently living through. 9 countries hold approximately 12,500 nuclear warheads right now. In 1983, a Soviet officer named Stanislav Petrov was sitting at a command station when the early warning system triggered 5 American missiles inbound. Protocol said report it immediately. The automated response would launch. He didn't report it. He decided it was a false alarm. He was right. A software error. Sunlight on clouds, misread by a satellite. If he had followed protocol, if he'd been slightly more rule-bound, slightly more trusting of the system, the chain of events that followed would have been automatic and irreversible. Not because anyone decided to end civilization, because a satellite misread sunlight. That was 1983. The weapons are still there. In 2017, a research group reconstructed a smallpox-related virus from mail-order DNA fragments for approximately $100,000. The knowledge is public. The barrier falls every year. We are building tools whose destructive potential vastly outpaces the institutional structures designed to contain them. The Astronomer Royal of the United Kingdom, Martin Rees, estimated in 2003 that the probability of human civilization not surviving the 21st century was around 50%. Not because he's a pessimist, because when he looked at the actual landscape of risks and thought seriously about humanity's track record of managing them, 50% was where the math went. Apply that number universally. If every civilization has roughly even odds of making it through its first dangerous century, and the odds may get worse as the tools get more powerful, then the galaxy is littered with planets that got to our exact moment and didn't make it through. They didn't leave ruins because a civilization that ends after a few centuries of technology doesn't build much that survives geological time. The silence isn't just absence, it's a pattern. And the pattern says, this stage right here, the one you're in, is where the record shows failure almost universally. But there's one more layer, one more piece of the answer, and it's the part nobody wants to be true. In 1973, a Chinese author named Liu Cixin was born. Decades later, he wrote a science fiction trilogy. The second book is called The Dark Forest. And The Dark Forest is not just a story, it's a logical argument, and several researchers have since examined it formally as a serious solution to the Fermi Paradox. It goes like this. Every civilization wants to survive. The resources of the universe are finite. You encounter a signal. You don't know who sent it. You don't know their values, their history, whether they're dangerous, or what they'll become in a million years. The cost of assuming they're safe and being wrong, extinction. The cost of assuming they're dangerous and being wrong, wasted resources. Under those conditions, survival as a goal, finite resources, genuine uncertainty, the mathematically dominant strategy is silence. Don't transmit, don't respond, don't reveal that you exist. And if you detect someone who doesn't know the rules yet, someone still broadcasting openly into the dark, the logic does not have a comfortable conclusion. Matthew Schwartz at Harvard analyzed the game theory formally. The dark forest equilibrium is stable. You don't need civilizations to be evil. You only need survival, scarcity, and uncertainty. Three conditions that describe virtually every scenario in the universe. Now put it together, the full picture.
The great filter is real, and it is almost certainly ahead of us. The evidence, Kepler, Webb, the accumulating data that life gets started easily, all of it points to the filter being after technology, not before. Civilizations arise, they develop tools, and then, almost universally, something terminates them before they become a lasting presence. And the civilizations that do survive, the rare few that navigate the transition, go quiet. They've either reasoned their way to the dark forest, or they've encountered something that taught them why broadcasting is dangerous. Either way, the conclusion is the same. Silence. Deliberate, permanent, rational silence. The galaxy isn't empty. It's full of things that have been watching civilizations like ours flare briefly and disappear, over and over for billions of years. Things that are not transmitting because they understand the game. Things that may have already picked up our signal. We've been broadcasting for 130 years. Our transmissions have now reached thousands of star systems and have had decades to decide what to do about it. We didn't choose to announce ourselves. We just existed at a technological level that produces detectable emissions. The announcement was automatic. That is the answer that's left standing when you push every other explanation to its limit. A great filter ahead and a dark forest around us. Most civilizations don't make it through the dangerous phase. The ones that do go quiet. And we are currently in the phase that most civilizations don't survive, broadcasting our location into a universe that may not be as empty as it looks. Here is the part worth sitting with. The civilizations that made it through, the rare ones, the quiet ones, they solved this. They found something the ones that failed didn't find.
We don't know what it is. We have only the logic of the situation, the shape of the silence, and the knowledge that it's possible, because otherwise the universe makes even less sense than it does. The math is not predetermined. There is no physical law that says we fail. There is only the historical record of what happens at this stage. The silence around us isn't background noise. It's a warning, and we're still deciding whether we're going to hear it. If this changed how you think about anything, the weapons, the AI, the climate, the politics that feels too small and too loud simultaneously, drop a comment. I read them all. And subscribe if you want to keep going down this particular rabbit hole, because the next one is about what happens after the filter. And I promise you, it's stranger.